One of your most common sources for linear regression is going to be using computer regression output. So it's important to know how to interpret this. So we're going to look at this example here, and I'll show you how you can interpret a linear regression equation from that, as well as interpreting the strength. You'll take a look here. We have height equals, and they even tell us looking for a regression of height on weight. And we get an equation here. And even give us the height equals, which is pretty nice. So it gives us a little bit of a start. So here are the important things you want to be able to pull from this. First of all, you'll notice here we have constant. This is going to be your y-intercept. When I start writing this, I can go with 13.348 plus, next I want my slope, which you'll notice is right below it, right here. This is my slope. Negative 0.156. And this is going to be times our x, which is going to be weight. And can't forget about height. Now, it would be helpful if they gave us the units here. We don't know if we're dealing with inches. We don't know if we're dealing with centimeters. We don't know if we're dealing with pounds. We don't know if we're dealing with ounces. But overall, you can see this is how you can put together a linear regression equation from a computer regression output. So remember, that top number here is going to give you your y-intercept. Then one right below it is going to give you your slope. Now, you can also look at the values down below, which we're going to do for a moment. Now, at this point, before you start doing inference, we haven't done inference yet, so we're just dealing with exclusively interpreting these equations. You can find your r squared value right here. So r squared equals 98.2. And if you remember, what that tells us is 98.2% of our data can be accounted for by our least squares regression line. And you can also use this to find your r value. So remember, this is r squared, right? So if I want to find my r value for this, I can do r equals the square root of 0.982, which I'm going to calculate right now. Oh boy. I get 0.991 essentially. So what that's telling me is I have a strong, and let's take a look. Notice that we have a negative slope. So I want to say we have a strong negative linear correlation. That's something that a lot of people tend to overlook. When they find their r value, they'll take r squared, find the square root, and then they forget whether it's positive or negative. Remember, you have to look to the slope here. And let's even take a moment to reinterpret that slope. So I'm going to take that down below here. It's important to be able to do all this, be able to really interpret what you got. So remember, slope is change in y over change in x. So we have negative 0.156, and that represents height. X represents weight. So I can say for every 1 unit of weight, whatever it is, height decreases negative, well, I have to put negative since I emphasize it decreases, but it decreases 0.156 units. So as you can see, I was able to pull a lot of information from this. Really able to pull a lot of information from this. And I can even use like given information to find residuals. Like, heck, I'm going to try something here. I'm going to try for weight. I'm going to plug in 100, see what happens. So I'm just going to copy and paste this so I have a little space down below. Alright, so let's plug in 100. So if someone weighs 100, whatever these units are, again, we don't know what the units are. They didn't really give us that clue. You can use that to try and figure out their height. Or at least what we would predict their height to be. Remember, it's all about predictions. Oh, hold on. I forgot to use a negative sign. That's important. Oh boy. I'd have to double check something here because something came out a little funky. I got negative 2.252. It was 13.348. What you notice I probably just did here was I extrapolated. Who knows what this could have given me? So I just did negative 0.156 times 100. And then I added the 13.358. And I got an answer of negative 2.252. That does not make much sense for my height here. So what you just witnessed here was the danger of extrapolating, and also probably the importance of knowing our units. We don't know our units here. So who knows what kind of units we're using here for height and weight. So that could even indicate that chances are we're probably not dealing with pounds here, because I would not expect someone 100 pounds to be negative 2.252 units high. Doesn't make sense. So overall, I want you to be able to take a look at reading this computer output for linear regression, be able to interpret it, pull some values out of it, be able to speak about the linear regression line, and ultimately you can use it for some extrapolation here, or you can, if you're given a unit, you could use it to find residuals. The important thing is you're able to pull an equation out of it and interpret